Aviation Maintenance Planning, the Aircraft Maintenance Introduction module. During this module we're going to look at some of the precursors and the history of what we now look at as our maintenance product. When dealing with complex technical systems and the extensive competition, the consequences of unreliable service become critical and may include a high cost of operation. If aircraft are grounded due to technical failures, it can be very expensive. We're not just talking, in fact, we're really hardly talking about incidents and accidents. Incidents and accidents are very, very rare, very, very few and far between. What we're talking about with our maintenance is a cost-effective product that gives us a reliable operation. Unreliable service may lead to annoyance, inconvenience, and lasting customer dissatisfaction. If people are not happy, they're going to go somewhere else. So, in a business that depends on customer support, and of course, aircraft operations is exactly such a business, then we must keep the customers happy. And to do that, we need to be on top of our maintenance product. A company can rapidly be branded as unreliable after providing poor service, whereas building up a reputation for reliable service takes a long time. It's critical for air carriers to achieve high standards of safety and reliable service while optimizing their profits. And there is a perfect example. These guys are acquiring, this is an Airbus A380 of course, they are acquiring an Airbus A380 every single 1 month. Every single 1 month they're getting 2 777s. That means at the end of the year, more than 20 777s, more than a dozen Airbus A380s. That's on top of their existing fleet of more than 200 airplanes. How to maintain such a product? By managing the customer satisfaction. To this end, aircraft operability is considered one of the major requirements. Aircraft operability is the aircraft's ability to meet the requirements in terms of operational ability and reliability. The percentage of scheduled flights that depart and arrive without incurring a chargeable technical or operational interruption. Typically, if the aircraft departs within 15 minutes of its scheduled departure time, it's considered an on-time departure. In 1979, the Air Transport Association sought to improve on MSG2. What is MSG2? MSG is the maintenance steering group logic which determines the type of maintenance activities that we're going to perform. We will go in very much detail through the entire MSG process. To address a new generation of advanced technology aircraft, the 757 and the 767, Boeing developed 2 airplanes simultaneously, and they had a very similar technology. They were using, instead of instruments in the panel, they were using screens. They had screens for the engine instrumentation called the ICAS, and they had screens for the flight control, flight director, radio altimeter, and so on and so on, called EFIS. This was a massive change from the previous generation of aeroplanes. And of course, this is the forerunner of what we've got now. All aircraft now have glass cockpits with LCD and so on and so on. Even smaller airplanes, brand new airplanes, all now have this method of presenting the information. There was some shortcomings in the decision logic, MSG2 logic. Did not effectively deal with the increased complexity of aircraft systems. The MSG2 process was 10 years old at that time. It came in at the beginning of the 1970s. Did not address regulations related to damage tolerance and fatigue evaluation of structures. In actual fact, the structural integrity and the corrosion prevention, corrosion protection programs were separate in the MSG2 environment. As I say, we will talk about this in a lot of detail. Whereas within the MSG3 environment, they're integrated. Corrosion prevention control programs and requirements mandated through an aging aircraft maintenance program. So, MSG2 did not differentiate between maintenance being done for safety reasons versus economic reasons. Sometimes we choose to do maintenance. Why? Because it prolongs the life of the component. We don't have to, we're choosing to. Therefore, the driver for that particular maintenance activity is economic. In doing so, we improve the cost effectiveness of the maintenance product. And what we should pay attention to, that the operator is responsible for the maintenance program. And the operator, through the reliability program, determines the effectiveness of the maintenance. Many operators simply copy the MPD and do nothing with it. It's not correct. Operators that understand the MPD and understand the maintenance process and have a strong and effective reliability program are able to adapt the maintenance program to suit the conditions of the operator. In doing so, you can optimize the effectiveness of the maintenance program. To do this, you need a particular competence within the organization. You also need a particular competence within the regulatory environment to oversee the organization. And so this is the challenges that the industry faces in having sufficient competence within the organization and sufficient competence within the regulatory oversight systems.